Welcome to this talk. This talk is called From Introductory to Advanced C++. This talk aims at providing a couple of learning guidelines, whether you are a person who's just starting with C++ or maybe you are an experienced C++ developer looking to further your studies revolving C++. My name is Slobodan Dmitrovic. I am a C++ trainer. Before that, I was a R&D software developer, and I'm also author of a couple of introductory books on C and C++. And this is my LinkedIn page, so I encourage you to connect with me, ask any questions you might have, etc. But I'm the least important thing in this presentation, so let's move on. So I'll try to provide an overview because over the course of 6 years, I've learned that introductory, intermediate, and advanced C++ means different things to different people, especially in different industries. So I will try to provide an overview, a classification of what it really means, what topics are inside the realm of introductory C++, intermediate C++, and advanced C++. Now, most of you are here in this room are experienced C++ developers, but we should always keep in mind that C++ can be a bit of a challenge, especially for newcomers who are coming into this to this programming language. It can even be intimidating, but that shouldn't really be the case. C++ is a complex language that covers a lot of ground, but it's no rocket science. Right? And they also say although used in one. So let's start with an introductory C++. What should you learn in the beginning? And I will provide just a rough overview of the topics. So first you need to learn about the C++ language itself, C++ basics. Then you need to move on to the C++ standard library basics. And we'll cover all of these into greater details later on. Once that is in place, you should learn about modern C++ standards. So this is a rough overview of the topics you should learn in the beginning, and in this particular order, shall we say. Language basics first, standard library basics second, and modern C++ features that are introduced in C++ 11 and subsequent standards. So it is really important to establish a solid knowledge base in the beginning, and that's easier said than done because C++ is a complex language that covers a lot of ground, so making a clear distinction between this is what you need to know right now and this is what you can do without is a lot of work, and basically it can be challenging even for professionals who are doing this from 9 to 5. So I should emphasize this once again. Establishing a solid knowledge base is your priority number one. So let's take a look at what does make a knowledge base, actually. So here are some of the topics that make up the essentials of the language itself. Some of the topics. We'll cover them into greater details later on. But as you can see, you should start with the declarations, definitions, built-in types. And then you move in complexity. Operators, operands make an expression, and expressions ending in a semicolon make a statement. So you shouldn't be shifting bits on your first day of learning, nor should you be learning about classes in the first day of learning of C++. Because there are prerequisites to learning about classes, to learning about functions, etc., etc. Now, when this is in place, you can move on to functions. And only then should you move rather to classes. So you should really avoid resources that are teaching you classes on a second page or on the first page, because there are plenty of prerequisites that need to be in place in order to start working with classes. I mean, we as experienced developers take it for granted, but for a newcomer to this language, this is really, it can be challenging, and it can even be intimidating, but it really shouldn't, right? So now this is particularly topic that there are pros and cons. So there are two schools of thought. One that says you shouldn't be learning templates in the beginning at all. And the other school suggests that you should learn only introductory template metaprogramming in the beginning. And we'll cover that as well. So why is only a brief introduction in the beginning advised? Because as Scott Myers says that C++ is a confederation of 4 languages, right? It has the C background, it is object-oriented programming language, has the standard library, and has templates. So if you're a newcomer to C++, going too deep into templates metaprogramming can be intimidating, it can be overwhelming even. So that's something that's, you should be gently introduced to templates in the beginning, I should say. Why I think it's a good idea to only ever so slightly be introduced to templates. Because the entire C++ standard library is implemented through templates, and you will get a better understanding about those verbose compiler errors that stem from the standard library. And of course, C++ language basics involves much, much more than those listed bullet points. Now, what are the standard library basics that you should learn in the beginning? Well, it's easy. You should learn about the containers, and you should learn about algorithms or functions. So one of the questions that often scares, one of the topics that often scares people away from C++, which shouldn't be the case, is that I often hear it, especially when in introductory courses. C++ standard library is so complex, I can't learn everything. Nor should you. Nor should you. You only learn what you will be needing in your line of work. And you can start with containers and algorithms. So the question now comes to which containers and which algorithms, and iterators as well. We'll cover that as well. So I'm now giving you a rough overview of the introductory C++. Let's dive deeper into the topic of modern C++ standards. What's modern C++? Well, we can all agree at this point that modern C++ means a lot of things. But I assume we can all agree that everything starting with C++ 11 onwards is considered to be modern C++. So that should be the bottom line nowadays when you are working with C++. The C++ 11 way of thinking should be the bottom line. It's not always possible. There is a lot of legacy code left. There is even C++ 98. But if you are starting with C++, the language essentials and the standard library essentials are the same in C++ 11, 14, 17, 20, and so on. It doesn't matter which standard you choose as long as you have at least C++ 11 way of thinking in mind. So that's very important. So initially, we should concentrate on the notable features. So when we say we want to learn a particular standard, what we actually mean is that we want to learn about the notable features that are introduced in these standards. Mission-critical industries are mainly relying on C++ 14 and 17. Not all, but most of them, in my experience. Because why do they rely on that? Because C++ 14 mainly rectifies a few shortcomings of the C++ 11 standard, and the mission-critical industry wants a tested, a reliable, fully implemented standard, and these 3 standards are that. And they basically opt for the bottom line to be C++ 14 because we have stood make unique, et cetera, and other features there as well. Most of them, some of them have already moved to C++ 17. But this should be your, how should I say, your basic knowledge base that revolves around C++ standards. So C++ 11, 14, and 17. with a strong emphasis, once again, with a strong emphasis on C++11 way of thinking. So that's the bottom line. Or at least should be, right? Okay, so let's focus on the language for now. And I will, in a moment, move to the intermediate and advanced topics as well. So these are some of the bullet points that should make a solid knowledge base, hopefully, that will enable further progress. These bullet points. Now, please note that I've left classes deliberately from this slide, which I will be covering in a separate slide. So this is in the beginning, things you should focus on. So you don't have to know about the type ID operator in the beginning. That's not relevant for you as a beginner. So this is one of those rare cases where you definitely don't want to know everything about the C++ standard library, and you can even get away without knowing a particular operator in the language itself. But these are rough overviews. It kind of looks easy if you list it like this, but determining what is it that you need and what's not so relevant involves a lot of work. Okay, now once this is in place, let's dive deeper into functions. So, what should you learn about functions? Well, it goes without saying, function declarations, function definitions. I think immediately, even if you are teaching newcomers in C++, you should, even if you are staying in the single source files in the beginning, you should get into, show them the good practice of dividing our functions into declarations and definitions. Even if it means you're staying in source.cpp and declarations go above function main and definitions go below, even before you start splitting the framework into header and source files. Because people often ask, so why am I duplicating this code? And we are just at the beginning of learning C++. And then because later down the line, we want to put declarations into header files and put definitions into source files. That's why we immediately get into a good habit of separating the two. Okay, so next, invoking a function goes without saying. And three main ways of passing an argument to a function. And it sounds superficially simple, but all newcomers to C++ should be taught immediately that built-in types are passed usually by value, because that's a more efficient way. Complex types are passed, and now it comes as an issue. We don't really like references per se, right, as function arguments. We more tend to use const references for function arguments, as that does two things: avoids creating expensive copies and makes our object argument rather read-only. So built-in types are passed by value, classes are passed by const reference. So those are some of the good habits that should be adopted right away, right? Especially when learning a complex language such as the C++ itself. Then you go on to show the uses of the return statement, whether a function does need or doesn't need a return statement. And finally, function overloads. So this is one of the things where C++ indeed starts to, especially for people who are coming with a C background. So there are no function overloads in C. So this is something that they might find, they certainly find it as a new feature, and they should be gently introduced into this topic. And now we come to the more complex things such as classes. So the relatively dry definition of classes is that they are user-defined types, but to a newcomer that doesn't mean much, right? So you should say classes are data and functionality on that data wrapped into one complex type, and we manipulate the internals of that class through an object of a class. So gently introduce them to the concept of classes. So you should start with the data members, declare a couple of data members, and immediately in the beginning, it might be okay even to put them data members while explaining introductory classes in C++, to put them in the public section. But I would advise against it. Immediately, we tend to keep our data members in the private section of our class. Then you go on to explain member functions. And when explaining member functions, they should also know that function definitions, member function definitions can be implemented in two ways, inside the class body and outside the class body. And then we proceed to creating an instance of a class, right? Initializing an instance of a class. So as you can see, there are a lot of things that need to be in place before we start to learn about classes. Visibility specifiers, very important. Often people ask, so why are there 3 visibility specifiers? And then you proceed on to explaining, because there are 3 actors. There is the class itself, there is the derived class, and there is an object of a class. So that's why we have these 3 visibility specifiers. And once that is in place, we should learn about constructors. Member initializer list, very important. Because people are tempted to initialize their data members inside the constructor's body, which shouldn't be the case. It should be the member initializer list. And we should also explain why that is the case. Again, Scott Myers, whose intellectual work was a great motivator for me personally, effective C++, modern effective C++, etc., etc. And destructors. So there is a lot to be said about classes, but this should make, I think, this should make a solid knowledge base. This should present a solid knowledge base. So now the question comes to, do I introduce operator overloading immediately to newcomers? Depends. Depends, really. You might or might not. If you are introducing overloaded operators, you should tell them that they shouldn't probably learn them by heart because it's easy to forget them, but they should look them up. And they should also understand that one operator can be implemented in terms of another operator, but basically CPP reference provides a solid foundation for overloading operators, and also books as well. So, which brings us to our next topic. What are the next steps you should take when learning about classes? Well, you should learn about copy and move semantics, operator overloading, and then from that point on, it becomes a matter of progressing towards polymorphism, 3 pillars of object-oriented programming, which is the inheritance, virtual and overridden functions. I mean, and how should I put it? Every step should be introduced so that the next topic that comes along builds on the previously acquired knowledge, and no forward referencing of some strange topics that might introduce confusion is advised in the beginning. It can be challenging, sure, but ultimately it's no rocket science, it's just a tool. So we have inheritance, we have encapsulation, we have virtual and overridden functions, and finally we should be introduced to the concept of polymorphism, or more precisely, the runtime polymorphism. If you are inside embedded environments, you might want to stay away from the runtime polymorphism. But that's another story. Do I feel that newcomers to C++ should be introduced to runtime polymorphism? Sure. A lot of code, many design patterns rely on runtime polymorphism. So definitely, those are some of the bullet points. Interfaces. Now, when it comes to interfaces, I think we should learn about abstract classes per se, And when it comes to the design of the abstract classes themselves, that's a topic for the advanced C++. We'll talk about that as well. So this is the second step in learning about classes, shall we say. Okay, so now we come back to the topic of how much of a template introduction is too much of a template introduction. Well, I strongly feel that you should learn about function template declarations in the beginning, ever so slightly, basic class template declarations, definitions as well, and only one topic, which is a very basic template specialization. So, and then we cut it off there. Because template metaprogramming is a topic of its own. A dedicated book on template metaprogramming is, if I remember correctly, around 800 or 900 pages. So that's a language within the language. But these 3 bullet points should provide a solid starting point, shall I say, that enables further progress. Once this is in place, then when we are moving to the standard library and we get that aha moment, so now stud vector is a class template, I now understand. And this helps in the beginning. But it's a constant balancing act, so one should be really, really careful about this. So in summary, only a brief introduction when starting with C++, only a brief introduction to C++ templates is advised. Okay, now we come to another topic, which is a topic of its own. How do we start learning about C++ standard library? Well, the standard library is a universe of its own, and arguably it's humanly impossible to know everything that is in the standard library, nor should we know everything that's inside the standard library. But for a newcomer in C++, it can be intimidating determining what is it from the standard library that I need and what is it that I don't need. And I think the right path forward is to be introduced to the widely used containers, such as stud vector, stud array, stud set, and stud map. And we should go through a couple of examples, a couple of member functions revolving around these class templates, around these containers. And that's it. We cut it off there. So now people that are coming into the world of C++ feel more confident. So we have containers that are rather easy to use, immensely useful. So now they are building the confidence to attack other subjects that are more involved in C++. And then it comes the question, you should also ever so slightly introduce iterators to the newcomers in C++. And how much of an iterator is too much of an iterator? Dot begin, dot end. Explain that dot end is pointing not to the last one, but one past last one. And if we are wondering why that is, we can, at this particular point, we can say take it for granted because we need a mechanism that ensures that if a particular function returns an iterator that the element was not found, we need to set it still to some iterator. And that's why we have this mechanism of dot end iterator pointing to the one past last element. And widely used functions. So the question comes to which widely used functions? Let's start with the simple ones. Stud count, stud find. And even in the beginning, we shouldn't pay too much attention to this stud find if variant of a standard library functions, because that's something down the line. But let's say stud find, stud sort, and then people are starting to appreciate the level of comfort, especially people who are coming with a C background, and there are no containers and there are no such functions in the C library, so they kind of begin to appreciate the level of comfort, arguably, that we have in C++ as compared to the C standard library. I should also mention that ever so slightly you should introduce the stud string, even before talking about functions, because it helps when explaining the topics about passing an argument by a const reference. That's why only a brief introduction to stud string is advised in the beginning. Why not too much of a string introduction? Because string is a class, right? And to a newcomer, even before learning about classes, it can be confusing. What is this dot member access operator? Why is this syntax so strange? So that's why ever so slightly we should be introduced to strings. Okay. Once again, you don't have to learn the entire C++ standard library by heart, but you should aim to establish a solid knowledge base in the beginning, shall we say. And hopefully, it becomes much easier to tackle the concept of, especially complex concept of standard library per se. So now hopefully you are better equipped to tackle other subjects. When I was a young developer, I even thought that I should know the entire standard library, but that's way, way back, 25 years ago. But that's not really the case, right? So that's a mistake every newcomer in C++ makes. This is so overwhelming, I can't learn this. No, you don't have to learn it. But it's there for our own convenience. If you have to use it, you'll use it, right? You will explore the standard library. Okay. So once we are familiar with the language basics and the C++ standard library basics, we should learn about notable features in subsequent standards, starting with C++11, right? So what should we start with? C++11 should be really the bottom line. I mean, if you're tempted to start with C, I think you should start with C++11 and build your way up. So when we are talking about C++11, and I'll mention a couple of, let's mention 6 bullet points that are the most important in C++11, shall we start? So smart pointers, move semantics, automatic type deduction, range-based loops, const expressions, etc., etc. So the list goes on and on. But a couple of biggest changes. I mean, C++ really made our life easier. It made the language so much more expressive, so easier to use. Initializer lists also. There we go. So you should start with C++11. So as you see, you can even limit the scope of learning about the C++ language to a couple of topics. You don't have to know everything about it. Then you progress to C++14 and have in mind that it mainly rectifies a few shortcomings of the C++11. And that's why the industries basically are starting with C++14, basically. Because we don't have stud make unique in C++11, but we do have it in C++14. And then you learn a couple of big features in the C++17 as well. Now, from this point on, you can move on to features in C++20 and 23. But if you follow these, hopefully these guidelines, hopefully they are useful. I mean, you are incrementally building up your knowledge. And no subject is too much of a complex subject if you have the proper path of learning and so. It can be, it's not the easiest language to learn, but ultimately, I guess that's why I'm employed. Okay, so what to learn next? Well, now we come to the interesting part. More interesting, everything is interesting about C++. So what are the topics that make up intermediate and advanced C++? Well, the lines are often blurred between the two, even between the three. But there is a general consensus of what makes an intermediate levels of knowledge of C++. So you should learn about the notable C++ idioms in C++. Definitely. Idioms cross the lines sometimes between the implementation and the software design areas, but you should know about a couple of C++ idioms. Then you should, maybe you don't, but maybe you should learn about concurrency through multi-threading, especially if your line of work requires of you to have a multi-threaded framework. And C++ does have provides wrappers around many of the facilities that revolve around multi-threading. We talked about runtime polymorphism. Also, this is not a requirement that you should follow, because especially if you are in embedded environments, well, sometimes there things are different, quite different. And then you want to stay away from the dynamic memory allocation, but that's a topic for another. All said and done, you should be aware of the runtime polymorphism, definitely, even nowadays. I mean, it's a huge part. And then you can move on to in-depth template metaprogramming. Then you should move on to in-depth template metaprogramming, especially if you are in embedded world, or maybe you are well, if you are a standard library implementer, then you probably never leave the realm of template metaprogramming. Right. This is a very important topic. So C++ is not the easiest language to learn, as I mentioned a couple of times, but there are guidelines and there are pitfalls to avoid, and there are do's and don'ts in C++ as well. So there are many, many guidelines, and they even differ across multiple industries. So the question comes to, which guidelines should I learn about, and which ones? I mean, there are so many of them. Should I follow the general guidelines? Should I follow MISRA guidelines or this and that guidelines? Well, the answer is that you should learn about a couple of them. You don't have to follow them to the letter, definitely not, because most of these guidelines are already built in static code analyzers. So let the machine do the static code analysis. But you should be aware of a couple of them. Pass, complex type, but by const reference. So that is one of them. But that's a common knowledge. We take it for granted, but that should be adopted as well. Avoiding pitfalls. Much of the problems stem from the undefined behavior and reading out of bounds. So don't read out of bounds. Don't read uninitialized memory, and don't cause memory leaks. So those are some of the guidelines we should adopt early on as well. Okay. And finally, inevitably, you should move to, I mean, you don't have to, certainly, but inevitably it becomes a matter of software design in advanced C++. Software design. So designing classes, as Scott Myers said in one of his talks, is a great part of our work, line of work, right? So those are some of the topics that you might include. Once again, I will say this really depends on your use case, on your industry, shall we say. But there is a general consensus that these topics should make, shall we say, intermediate and advanced C++ programming. Now, there is a lot to be said about any of these topics, and there are a plethora of other topics as well. But once this is in place, it becomes much, much easier to tackle other subjects as well. That's not rocket science, ultimately. So let's take a look at a couple of idioms. And this is well, this subject is a touchy subject because some people prefer some idioms, other people prefer other idioms. But you should learn about a couple of them. We can all agree that erase and remove idioms should be known by all of us. Resource acquisition is initialization. Immensely, immensely powerful technique. Should be introduced. Everybody should know about it. The erase remove idioms. So when physically removing elements from a sequential container, it's not enough just to erase or just to remove, but in combination with the two, it becomes the actual removal of elements. So that should be explained as well. Learned, rather. Pointer to implementation. I mean, idioms, some idioms receive more critique than others, but they are building blocks, that especially building blocks that lead up to the software design. We should be aware of a couple of them. Other idioms. Etc., etc. So, but you should learn about, you don't have to learn about all of them. Maybe even there is a gap on the market currently that a book is lacking that should list all the idioms, shall I say. That can be an idea. Okay. There is a wiki page that lists a couple of them. So if you Google C++ idioms, you will be eventually greeted with this particular page. But some of them we should definitely know about. Concurrency through multi-threading. Now, we have wrappers and we have support for multi-threading in C++, starting with C++ 11. So you should learn about stud threads, mutexes, locking mechanisms, futures, promises, etc., etc. And here are a couple of bullet points that should get you started in the right direction, shall we say. Now, concurrency, I mean, multi-threading is a topic of its own, and one needs to be really careful. But if you're gently introduced into these concepts through stud thread and different locking mechanisms and mutexes, then it becomes eventually easier. That now it's a topic of its own. And so if you are interested in more details about this, I can highly recommend the book by Anthony Williams, Concurrency in Action. Amazing book. So that's the one you want to probably read. Polymorphism, you should learn, as we said earlier, about virtual and overridden member functions. And now this is interesting. People often ask, which pointer should I use in C++? And the answer is this one. Stud unique PTR. So the question comes to, should I learn about raw pointers? I mean, we tend to stay away from raw pointers because raw pointers and raw arrays cause problems, especially in the world of C++, right? Potentially cause problems. So this one was meant as a replacement for a raw pointer. It's hard to quantify the amount of time you'll be using stud unique pointer, but let's say 90% of the time you'll be using stud unique pointer, and the remaining 10% or so you'll be using the shared pointer, but numbers vary. It really depends on your use case. Nevertheless, prefer smart pointers to raw pointers. But nevertheless, you should learn about raw pointers if only to discourage their use. If only to discourage their use in favor of smart pointers, and especially there is a lot of legacy code left, so one needs to be familiar. Even if to refactor the code, one needs to be familiar with this. Creating and using interfaces. We'll get to the topic of creating and using interfaces because that's in software design. If you don't want to use dynamic polymorphism, runtime dynamic polymorphism, you might explore curiously recurring template pattern, maybe even stud variant in combination with stud visit. A good book about software design in C++ is by Klaus Eagleberger. I highly recommend it. If you are interested in software design, in C++ especially, Google for Klaus Eagleberger and his book. Very well presented, very well. He talks about all of these topics in greater details, revolving around software design. And then when it comes to the question of, so what are the next steps about template metaprogramming? Well, once we learn about the basics, we should learn about template inheritance, maybe some specialization with templates, explicit instantiation, and plethora of other topics as well. But these things should get you started. Template specialization. How can I inherit from a template? What does it mean that I explicitly instantiate some portion of a code, etc. So those can be some of the guidelines. But the templates themselves is a complex topic. It's a language of its own, right? Now you should learn only about some of the C++ specific guidelines. You should be aware of them, I should say. You don't have to learn about them by heart, but you should be aware about some of them. Different industries provide guidelines of their own, shall we say. Common pitfalls to avoid, do's and don'ts in C++. I can highly recommend the work of Scott Myers. His intellectual work back in the days was a thing that got me interested in greater details about the language, and here I am, fast forward 15 or so years, and I was really inspired by his work. So Scott Myers, even up to this day, you might find some interesting topics in his effective C++ book even, but modern effective C++ is what you want. Now, I should say that you don't have to know everything, nor should you know everything about these guidelines, because most of them are baked into static code analyzers, and that's a good thing. And then we come to the topic of software design. Inevitably, if you are progressing, and so if you're progressing through these different levels of knowledge, not knowledge, but experience, and inevitably you are either becoming a manager or you are becoming an architect, right? Especially in software development world, or both maybe. But let's focus on the software design for the moment being. So software design is C++ is a powerful language that allows you to shift bits, but at the same time, it's a language that allows you to soar high with abstraction mechanisms. And those abstraction mechanisms are classes and templates. Now, that being said, it covers a lot of ground. So that's where the complexity of the language stems from. It covers a lot of ground, really. So if you want to design software using C++, you should be aware about the solid principles, shall we say. There are a couple of them, and there is the dry principle, there is the solid principle, there is even the Yagni principle, but solid is really nice. Then you should learn about some of the design patterns. So, some of the design patterns, not all, but some of them. You should be aware of. You should be aware of that there are three categories of those software design patterns. Why is this helpful? Because we want to create an elegant and maintainable framework. And this is very important, the separation of concerns. Now, I will oversimplify this. Why is this important? This class does this, that class does that. I mean, this is a super simple view of designing. But separation of concerns is immensely important topic you should adopt, especially when designing classes, and designing classes that interact with each other. So there is this old book about design patterns, The Gang of Four, but Klaus Eagleberger wrote an amazing book about, for the most part, about design patterns that revolve around C++. And he also provides an overview of the solid and other principles. So when we start breaking things into smaller chunks and putting them into, we say we introduce different variation points. I highly recommend his book, so you might want to look at it. So inevitably, advanced C++ revolves around software design, designing elegant classes, designing elegant interfaces. And these principles also explain how the interface should be designed and how it should not be designed. So basically, this is a rough overview of the things you should learn when progressing from the beginning in C++ to more advanced topics. And I will quote other authors. You are here for a long run, so this is not a sprint, this is a marathon. You don't have to learn everything, but these are the core and essential topics that you should probably, hopefully, pay more attention to. There is a lot to be said around many different topics, but it really depends on your use case, on your niche. Maybe you are in the embedded world, if you are in embedded, put your focus on templates. Put your focus on C++ 11 features that efficiently map to hardware. So if you are resource constrained in such environments, if your hardware is resource constrained, then that's a whole other ball game, right? But determining what is it that is important for you and what is it that you can do without is basically it's a full-time work. Okay, hopefully this wasn't too overwhelming, not too underwhelming. I'd like to thank you for your attention, and I am looking forward to your questions, and let's dedicate the remaining time we have to your questions, whatever they might be. I'll do my best to answer them. So thank you once again. Thank you. Yes?
If I understood you correctly, you said you first teach some basics on C++ and then later start with the C++ 11, 14, 17, and so on features. At what point do you think that some of those later, more modern features or later standard features become part of the basics? I think, for example, about range 4, maybe unique pointer. Maybe in 2 years' time, we will think about contracts as basic features that we should maybe teach in the basic section instead of like waiting to actually get to these later standards.
Right. So most of my time is spent in the industry, and all the practices I draw mainly stem from the practices adopted from the mission-critical industries. And they mainly rely on C++ 14 and 17. But you raise a valid point. At some point, we should start introducing contracts, as you said. But I'm a huge believer that for a complex language such as the C++, ever so slight incremental steps should be taken that make up the solid knowledge base, and that enables further progress. Once essentials from C++ 11, 14, and 17 are in place, then we can move on to C++ 20 and 23, which I think will be more prominent and adopted once the compilers fully implement the two standards.
Thank you.
You're most welcome.
Hi, hello.
Hello.
Thank you for the talk. For me, one of the biggest issues, starting with C++, was the build systems and the compile ecosystem, like the compiling stages, linking, and everything. Doing that in Windows, then in Linux, because I didn't study systems and I almost was self-taught. So that for me was a huge pain. And so how do you approach this for for the newcomers?
That's a good question, and one that often pops up. I personally, my line of work mostly revolves around idiomatic C++. And build systems are not tied to the language itself, shall we say. I mean, they are used in practice, but they are not tied to the portable C++ itself. So most of our trainings, there are people who do these dedicated trainings, should I say. Most of our trainings revolve around idiomatic portable C++ per se, and building libraries through various different systems, whatever they might be, CMake, Make, Microsoft's build system. That's something I delegate to other people who specialize in these terms. So often, good thing you ask this, because people often when they are starting with C++ ask, which build system should I use? And I say that's something down the line. You will not be using any build systems currently. We'll be staying in a single source file and compiling on command line, or if we are on Windows, we'll be using Visual Studio there. So I would say there are people who specialize in these areas. So you might want to look at their work as well.
Okay, thank you.
No problem.
Yeah, I was wondering in the beginning when you said algorithms and containers are one of the earlier topics, how important do you think it is that beginners should implement this themselves once before using a library? Maybe not all of them, but some.
Right, that's a good question. So the question is whether you should, when learning C++, learn to implement the containers of your own. Is that correct? It really depends. If you are, when I'm teaching C++ at universities, but even then I say that's not important because I specialize in the language itself. I don't think, because that's a kind of a C thing, right? But it doesn't hurt if you learn to implement a linked list. But what I do say in my training, we already have them implemented in the standard library. So from the perspective of learning about the computer science, I guess it is important. But when learning, that's not to say that even production software creates containers of their own. They do. But I think you should put focus on, it can be helpful if you're learning about what a doubly linked list is, what a singly list is, what a binary tree is, then it can be helpful. But we already have binary trees. We already have doubly linked lists in C++, so we just learn to use them. Hopefully that answers the question.
Okay, I'd like to expand upon the question about when to teach which features from the standards, because I think some of the best features we got in US standards are actually simplifications of what we had before, not so they don't really make it incrementally harder to understand, but more like easier, like range-based for instance, or even just lambdas, because I find it hard to introduce the more complex functions of the standard library, like if we do std sort and we want to put a custom comparator in there, it's much easier if I taught lambdas in conjunction with it than if I make them write an external class template, class with some overloaded operator or something. So do you think there's some merit of introducing some features from newer standards first and then later explaining how you would have to work around the lack of those features in the previous version?
Okay, so the question becomes to, should I learn about the features and then walk my way backwards to try to
at least for the features
simplify them? No, I think you should establish a solid knowledge base, and only then should you move to such features. That would be my personal advice.
Okay.
Thank you for your talk.
Thank you.
One interesting thing for anybody beginning of a language is doing like hello world.
Right.
I/O becomes always an issue. I want to see what's happening. Now, if you stick to like 11, 14, 17, you have I/O streams and the printf family of things like that, but you don't have print line yet.
Indeed.
How would you approach that, and maybe other I/O aspects like file network and things like that?
Great question. There are two ways to explain hello world in C++. You can either go 25 pages of deep technical analysis and scare people away, or you can simplify it in a couple of sentences. And a couple of sentences are, the std_cout object represents our console window, to which we output data using the stream insertion operator. And why is that important? That's important from the psychological standpoint for newcomers. Because if you are explaining the hello world to a newcomer in great technical details, then you are running the risk of demotivating them about learning C++. As when it comes to standard input and output, currently I personally still stick to std_cout object. And actually we haven't in these trainings have the need to introduce print line and printf and so on. So we stick to the idiomatic way, a bit maybe even outdated way of outputting data, but yeah, you don't have to go. I feel that too much energy is spent on going into every single eventuality about the standard output. And once you explain to people that maybe even your program doesn't care about standard output, maybe it sits somewhere as a process doing some hard background work. So there is no standard input, standard output, per se. But yeah, I think we should stick to std_cout. I mean, even when explaining a simple concept as a hello world, you have classes, you have overloaded operators, you have, even if you're explaining the function main as a main entry point, you have arrays, pointers, and it becomes unclear to people who are completely new to C++, what is this all about? Where is my hello world, right? So I strongly feel that in the beginning you should refrain. This is our function main, it is our main entry point. We output the data to the console window through the std_cout object, even if it gets replaced with print line. And it has this operator that it internally uses to output the data to our console window. And then we explain about std_cin and std_getLine, but that's also another story.
Thank you very much.
No problem. Thank you.
Hi.
Hi.
First of all, thanks for this great talk.
Thank you. Appreciate it.
Regarding this kind of classification of this progressive step in the learning the language from the introductory to the advanced level. So my kind of thesis is that it's difficult to draw the line what is between these kind of levels. I would say these boundaries are kind of artificial, and I believe that one should know kind of all these main basic building blocks of the language,
right.
And what is distinguished is basically the proficiency is how deep you in this particular area. So at least my
yes.
What do you think about this?
Lines are often, there is no clear line in classification of what makes introductory, intermediate, and advanced. I mean, you would be surprised as to, if we represent them by circles, you would be surprised that they overlap. Even 3 of them are overlapped. So the answer becomes, hopefully, meaningful answer is it means different things for different people in different industries. Because it's a different way of teaching C++ in universities and different way of teaching C++ to experienced engineers in mission-critical industries. So those are 2 things. And I personally have to adapt. Most of my time is spent with the industry, but I have to adapt when teaching in C++. I try to teach the same C++ the same courses in both the industry and academia, but it's not always possible. So, for example, take a stud list. Take, for example, is it used in production or not used in production? So, academic circles very much like to use that particular container. Maybe in production, some industries do not. And also, one of the questions that popped up, this is interesting. I was teaching the move semantics, only the basics about move semantics in introductory to intermediate levels. And one of the participants asked me, well, if we are learning this now, what makes the advanced C++, right? So it means different things for different people, basically. But there are no clear lines, and often they overlap, indeed. Hopefully that answers the question. There was a question back there, if
there's still time.
Sure.
Thank you for this interesting talk.
You're most welcome.
When you talked about standard library basics, then you basically enumerated a subset of the standard template library in the order of containers, iterators, algorithms.
Correct.
If I understand correctly, when Stefanov designed the STL, he considered algorithms the main part of it, and containers are just a tool to apply algorithms on data. And I was wondering if there would be value in teaching directly the history of the STL and the design concepts behind to understand better how the 4 pillars of the STL interact with each other. Or is it too early?
I don't teach those pillars, and I do mention that once it was called standard template library, and nowadays it's called C++ standard library. So to draw the line about that it is a library of useful functions to us developers, useful functions and algorithms we use in our program while including after including the appropriate header file. So that's how I think we should treat the standard library. But as it turns to, I mean, that's a story of its own. A generic meta, I do mention that we are now programming for types. We are not programming for, with types in mind. We are not programming, but no, I think with the standard library, as the name suggests to us, it's a standard library. It's a library of useful tools. So I think that should be, and that's how we use it in production, basically. As to design of the standard template library, well, that's beyond my scope.
Thank you.
No problem. Okay. Please feel free to ask any questions.
We are out of time, unfortunately.
Out of time, okay. So I would like to thank you once again. Hopefully you found something useful in this talk, and thanks once again. Appreciate it.